Hi everyone! We're going to be learning a new topic today, which is converting between standard form and vertex form for a parabola. So we've been talking about parabolas for a while. Let's get right into it. Let's do the do now. It says algebraically determine and state the vertex of this parabola. I'd like you to try it and then pause the video, and then when you're ready, unpause it and I'll go over it. Okay, so if we're stating the vertex, the first thing we need to do is find the axis of symmetry. Okay, so we need the formula, which is there on the right, x equals negative b over 2a. So let's see, a is 1 and b is 2. Remember, a is the number in front of the x squared, b is the number in front of the x. So x equals negative b, so negative 2 over 2 times 1. So that gives us x equals negative 1. So the axis of symmetry of this parabola is x equals negative 1. Now to find the vertex, we need to take that negative 1 and plug it in every time I see x. Okay, so when I plug that in, you can use your calculator to do that for you, and you get y equals negative 9. So be sure that once you find the y value, that you're actually writing the vertex. The vertex is an ordered pair. Remember, an ordered pair is an x and a y, x comma y. So negative 1, negative 9. So there's my axis of symmetry and my vertex. Okay, so part B says, is y equals x plus 1 squared minus 9 equivalent to y equals x squared plus 2x minus 8, and justify your answer. Okay, so let's take a look. What we're going to learn, before I even do this part of the question, is we're going to learn that we have two forms of a parabola. We have standard form, that's what we've been working with. And we have what we call vertex form. They are the same. These two parabolas, as you'll see in a minute, actually are the same. Just like this is similar to when we do factoring. If I gave you x squared minus 9, or you factored into x plus 3x minus 3, you know that those are the same. It's just a different form. Just like standard form and vertex form are the same exact parabola. It's just a different way of writing it. So actually, let's go into our calculators and take a look. So let's go to our y equals, and let's type in the original. Let's type in x squared plus 2x minus 8, and let's look at the graph. Okay. So I'm just changing the window. If you hit zoom 6, you should be fine. Okay, here we go. So actually you can see we figured out that the axis of symmetry was x equals negative 1, which it is, and you saw that the vertex was negative 1, negative 9. It's a little, this one's not quite as easy to see as if you're using your real calculator, but the vertex is negative 1, negative 9. Oh, it even shows you right there on the window. Okay, so now what I want to do is I'm going to leave that one in there. That one's blue. And now I want to type in the other one that they're asking us. X plus 1 squared minus 9. Okay, and let's go to graph. Okay, so you can't really see the blue anymore, but the blue and the red are the same. So that what we're seeing, since we don't see two parabolas, is that these two are exactly the same. They're just in different forms. Okay, so the one that we typed in first, that was the standard form one, that's this one. And then the one that we typed in second, that was the vertex form. Now, if you want to see if they're the same, what I can do is I can take the x plus 1 squared minus 9, and let's multiply that out. So x minus 1 squared, x plus 1 squared is x plus 1 times x plus 1. So let's do the box on the side. We know how to do that. X plus 1, right, when we're multiplying two binomials. So we get x squared plus x plus x plus 1. So I get x squared plus 2x plus 1, and then I still have this minus 9. So I will minus 9. So that leaves me with x squared plus 2x minus 8, y equals. So yes, they are exactly the same, just written in different forms. Again, this is standard form, and then this other one is vertex form. But notice, once I multiplied that out, it brought me right back to standard form. So it's easy-ish to get from vertex form to standard form. We multiply out like we just did here, like we did in this whole thing. It is a little harder to get from standard form to vertex form. And that's what we're going to talk about today. We're going to talk about converting from standard form to vertex form. And we're going to do this by a form of completing the square. Now, I know we did completing the square, I would say probably about a month ago. And we're going to do a form of it here. It is a tricky skill to learn. So we'll spend a few days learning it. So just for today, I'm just having you follow along with me. Okay. So here are all your steps. I'm not going to read them all, but they're all there for you if you ever want to refer back. And I'm just going to kind of talk us through it. Okay. So the first thing it asks us to do, it says, using the process of completing the square, write the following quadratic functions in vertex form. State the coordinates of the vertex, the turning point, once we're done. Okay. So the first thing that we are going to do is we're first going to make sure that the number in front of the x squared is a 1. We did that back when we did completing the square. And in this case it is. I'll just highlight what I'm talking about. There is just a 1 in front of that x squared. So that part is good. We're going to now, the second part is move the constant term over to the other side, which we've done. That was another step when we completed the square. So I'm going to move this 12 over. The only difference is now I'm going to have a y plus 12 on this side, and then x squared plus 4x on this side. I'm still going to add those lines that I like to do, so we remember we need to add something. And then I'm going to do the next step of completing the square. I'm going to take half of this b value, I'm going to take half of 4 and square it. So 4 divided by 2 is 2, and I'm going to square it. So I am going to add 4 to both sides. Okay. Now the next step I'm going to do is I'm going to take this side and I'm going to factor it. This is all still exactly the same as when we did completing the square, because it's the same steps. We're just going to stop at a certain point. So x squared plus 4x plus 4, we can factor. It's going to be the same number twice. It's going to be x, and then if you remember, I said it was this number that I just drew an arrow to. It's going to be x plus 2 times x plus 2. Remember, we're looking for two numbers that add to 4 and multiply to 4. The only two numbers that add to 4 and multiply to 4 are 2 and 2. We'll just add on this side. So 12 plus 4 is 16. And then what's nice is we had more to do when we did completing the square, when we learned it the first time. This is just a form of completing the square to get into vertex form. So we really only have one more step. We're going to write this as x plus 2 squared. And then all I need you to do is minus the 16 over to the other side, and we are done. So again, these two are equivalent. They're the same exact parabola. One is in standard form. That's this one. And one is in vertex form. That's this one. And we can actually easily see the vertex. That's why it's called vertex form. We're going to take the number next to the x. So in this case, it's x plus 2. And we're going to make it negative. So it's going to be negative 2. And then we're going to take the number by itself and leave that as is. So the vertex is -2, -16. You know what? Let's go to our calculators again. And let's type these in. X squared plus 4x minus 12. Okay, let's go to graph. So we can sort of see it. We might need to, if you go to your window, we want to see more down. We want to see more y min. So I'm going to go and I'm going to make that -20 instead, just so I could see a little more. Okay, so the vertex, oh, it's kind of hard to get. Let's do second calc. Let's do minimum. I'm not sure if, oh, sorry, I can't do that. Didn't know. Okay, so let's just go back to the graph. So if you can kind of see, like I said, you can see it more easy probably on your calculator, but it's -2, -16. But what I'm really interested in is I want to type in what we found to be the vertex form. Looking back at your notes, it's x plus 2 squared minus 16. So one's blue, one's red, the parabolas. When we graph, the red graphed right on top of the blue, which is showing us that they are exactly the same. Let's try one more together. Okay, so x squared minus 8x plus 11, and they want us to use the process of completing the square, write it in vertex form. Okay, so the first thing I do is I make sure that the number in front of the x squared is a 1, which it is. Okay, then the next thing I do is I move the constant, which is the 11, over to the other side. So I have y minus 11, I'm going to add a little line, x squared minus 8x, and I'm going to add a little line. Okay, now when I complete the square, the next thing I do is I take half of the b value, half of the number in front of the x, so that's -8. I'm going to divide that by 2. It's -4. And then I am going to square that, so I get 16. So I'm going to add 16 to both sides. Okay. So I could just add on the left. I get y plus 5. And then on the right, I need to factor that. X squared minus 8x plus 16. It's a trinomial. It's going to factor to be x and x. And I need to find two numbers that multiply to 16 and add to -8. Two numbers that multiply to 16, add to -8. Again, it's always going to be this number, the half of that middle number. So if that's easier to remember, it's x minus 4, x minus 4. And then we ask ourselves, how can I write that? It's x minus 4 squared. So this is the same as when we've completed the square. What's nice about this actually is we're practically done. All we have to do is move the 5 over. I'm going to erase that so it's not confusing. And we're done. Here we are in vertex form. So vertex form, standard form, they're the same parabola. So if I'm asked to write the vertex, remember a vertex is an ordered pair, meaning it's an x comma y. I'm going to take a look at the vertex form, and it's opposite of the sign inside the parentheses. So it's x minus 4. So I'm negating that. So it's -4, which is just 4. And then it's whatever this is outside. So 4, -5. The vertex of this parabola is 4, -5. Okay. Like I said, I know this is a tough concept. So for today, all I want you to do is submit your notes, what we just did, and then in our next class, we will do some more with this, some more practice. Bye for now, everybody.